Recorded? Okay, so here we go. Taylor has asked about how to make sure that the functions are set up properly in the library, and then how to import them and bring them over to your actual code so it works properly. So I'm just going to share my screen here, and I just randomly picked step 9 for this one. So our goal for this, I'm going to ignore the world info, but the goal for this one is to collect all of these dandelions on the way down, and then move back, dump all the dandelions, and then proceed to the finish line. We are not quite at looping yet for Reborg, so I'm not going to use any loops in it. But I am going to use the library functions. There's actually a much better way to do this one using loops. Let me just double check here. Oh, you can use repeat in this one. Okay, so we are using loops. So I will use those, but the most important thing in what I'm going to go over here is how do we define functions in the library and how do we bring them over. So I'm just going to start in our library, and there's a couple of, it usually saves your functions in the library if you're using the same computer and web browser. So you'll notice that if you log back in and go to a different step and you go to your library, you probably still have a lot of those common functions still in there. So that's handy, so you don't have to like recode everything. Also, if you were to use this guy to load an existing project, it would have all your library functions in there. So there's a couple, there's several functions that I use almost all the time, and one of those would be turnaround. So if we put in def turn underscore around, you don't have to use the underscore. In fact, my favorite method is using camel case. Went through that in I believe module number 1. Using either snake case or camel case. Snake case is the one with the underscore, and camel case is the one where you just capitalize the first letter of every word as you go on, and make sure that you've got the first letter always as a lowercase. Reborg does use snake case, so I guess I'll use snake case is fine. Either will work, but the point is you don't want to have spaces in your function, because no matter what language you're using, if a variable name has a space, your program will break right away, because it thinks that the first word is what you want to call the variable, and then it doesn't know what to do with the space. So that's why we always have to include either the underscore or to make it into sort of a single word using that camel case. So let's just try turn around. Some things that often cause syntax errors in Reborg, it's often very, very little things, and they can be frustrating to find because it just tells you there's a syntax error and it doesn't tell you where it is. And even if it does tell you what line it thinks it's on, it's actually usually wrong, because the error will be higher up, but it doesn't realize it until it gets to a certain point. So these are things to look out for when you're building your code in Reborg. If you're making a function, you make sure you always gotta have those 2 brackets there. That's something that'll give an error right away. And then you also, if you're defining a function, you need to have the colon right after it. Next thing is white space. I've seen a couple people ask questions about making a function and then they'll put an if statement and an else right after it. It doesn't recognize that if and else belongs to the function unless it's properly indented. So sort of like Tupperware containers, you could have a big Tupperware container, just plastic container that you put stuff in. And then you could put a smaller one in and a smaller one in and a smaller one in. But if you don't indent them, it doesn't realize that the second level is actually inside the first one. So you have to make sure that when you're using if statements or you're defining functions or doing loops, anything that you want to be included in the top level thing needs to be indented. Otherwise, it thinks it's a new sort of line of code, new structure. So in this function, I want to do several things. So I want to make sure those things are lined up properly inside the function. The turnaround function is really just turning left twice. So all I need to do is I need to turn left once, and then I need to turn left again. Now, there's no colons on these ones because we're actually using the function, whereas in the top line, we're making the function. So that's why there's no colons here, but they all need to have the brackets. So there's one function that I use quite a bit, and because you can see it's indented for the turn lefts, that is what tells Reborg that those 2 comments are part of the top level defined turn around. So I'm going to go back to the far left margin now. I'm going to make another one that's normally used, and that is a turn right. So I will make a turn right because there's a turn left, but no turn right. So I'm going to make a function called turn right, and in order to turn right, we have to do the extremely inefficient method of turning left 3 times. This is the Derek Zoolander of computer code. If you've ever watched Zoolander, you'll know what I'm talking about. If you haven't, don't worry about it. So there's 2 functions that I use quite a bit, and so I just sort of keep them in the library and bring them out when I need them to. Okay, so those are formatted properly. So ideally, I should be able to go back to my main code, and I should be able to use those. In order to use things from your library, you have to import them. And if you import them in the wrong way, you're going to get that syntax error again, and it's kind of hard to diagnose exactly what the problem is. So here's some things I've seen from people who have sent me emails saying it's not working, and I don't know why. You always start with the from, and this tells it where to go get the stuff. In Reborg, there's only one library. It's just your library tab there. When we move into Python, you're going to have like hundreds of different libraries full of functions that have been included with the program to make your life easier. So you have to be a lot more careful about picking and choosing what you import. But for Reborg, there isn't a whole lot to import. So I'm going to show you 2 ways. I'm going to show you some common errors that I've noticed from students who have been sending me questions. So from tells you I'm looking into a certain library. So from library. Okay, so it knows where to look. Now you have to import something specific or several things. So the way that you can import certain items but not either items is to just name them. So I know I only have 2 functions. If I only wanted to bring in the turn right, what I would do is I would import turn right and not include the brackets. If you include the brackets, it'll break. So if I include the brackets, it looks like I've done everything properly, but when I try to use it, it's not going to work. So let's just say I try to move, and then I try to turn right. And I think I should be able to because I have imported it, but when I run my code, it breaks right away and it gives me a syntax error. And it's such a minor error, but this is why it's happening. Okay, when you're not using a function, you're just kind of asking for it to bring it over from the library. You have to take out those 2 brackets. So if you take out those 2 brackets, it should be able to bring it over. So now you can see it brought it over and it used it properly. Now we didn't solve the problem, but we did actually successfully go to our library, grab the turn right, bring it over, and it knew where to find everything. And you can do that with as many of them as you want. So you can sort of, if you've got 10 things in your library, you can pick the 2 you need. So I could bring them both in just by going, I think the other one was called turn around. So again, I'm going to make sure that I don't have the brackets after it when I'm importing it from the library. And now I should be able to put a turn around in here as well and have it work properly. So I run my code, it turned right, it turned around, no problems. Okay. So that's one thing right there that students have make some simple errors on is not including the brackets, or sorry, including the brackets when they shouldn't for this part. So that should fix some of the common syntax errors. What I typically do with smaller libraries, again, we only have 1 library in Reborg. We don't have to worry about it pulling so much information that it slows down our computer or uses an unnecessary amount of resources. So one way that you can quickly bring everything over without having to type everything is, instead of typing out what the functions are called, if you just put star or asterisk. Asterisk is just is sort of a general computing symbol that says anything. So, you know, if I was going to my email, for instance, and I wanted to search for an email from anybody named Dunbar, I might be able to search. Let's just pretend it's a search bar, right? I might be able to type in on my search bar star Dunbar. What that would do is it would find all of the Dunbars. It would find the Mr. Dunbar and the Mrs. Dunbar and the John Dunbar and the Mary Dunbar, etc. So star has a couple of purposes in programming languages, but a lot of times it really means anything. Okay? So anything before that star would be fair game as long as it had the back part, the Dunbar part. And in this case, when we're doing our library, importing the star just says, go to my library and import everything that's in there so I don't have to type things out one at a time. So from this point forward, you can feel free to use from library import star instead of making a big list of all your all the functions that you want to bring over, and that's fine. The other thing that star is in mathematics, in programming, is the mathematical operator multiplication. And you'll see that as we move into our Python unit. So if I were to do 5 star 4, the computer would return 20 because it treats it as multiplication. information. So those are the two instances you're going to see the asterisk or the star in computer programming. But in this case, it means go to my library and import everything. Now I should be able to run my code again without any problems because it brought both of those things over and it knows what to do when it hits those things. Okay, so that's how you define a function properly. Again, the most important parts are up here, make sure you have the brackets and the colon. Make sure that everything on the second line and beyond that belongs to that function is indented. And if you are doing a function or calling a function inside the one you just made, in this case, we're calling the turn left function. It's a move or an operation or whatever, but it really is a function. It's just a built-in function, so we didn't have to actually tell the computer how to turn left. It was one of the ones that was given to us. So that's all very important when you're making a function. And I'll show you, if you make a mistake with your spacing, for instance, it's going to cause you trouble. So it looks like my functions are correct here, but what's happening and what's going to cause us a problem is because this one is not out on the left margin, because it's been indented, Reborg is going to think that all of these lines belong to the turnaround function. And that's how Python works. That's how Reborg works, because Reborg is really just using Python. Anything that's indented is going to be treated as part of the thing above it that's not indented. So because turnaround is not indented, it's like the big plastic container, and then everything that's indented goes inside the big plastic container. So it's treating everything here like a second level inside that initial container. So when I try to run this function, it's going to give me a syntax error because it doesn't know what to do with. It says turn right is not defined. Well, it doesn't know what to do with this because it's getting confused. Why is this indented? If this line wasn't here at all, the function would work, but it wouldn't do what we're supposed to do, right? Instead of turning around, he's going to turn left 5 times because it thinks that all 5 of these belong in turnaround. So it won't break, it won't give you an error, but it also won't do what you want it to do. So if I run this, turn right. Where do I have turn? Oh, I got to get rid of the turn right, sorry. So if I try to run my code here, it's going to work and it's not going to break, but it's not going to do what I want it to do. He's just spinning in circles right now because he thinks that he's supposed to turn around, or he's supposed to turn left 5 times as part of the turnaround function. So it's called white space issues, but really what they're talking about is the number of times that you hit the tab key or the number of spaces that you have between elements. It's really important in Python. It won't work unless you've got your white space correct. So in this case, we need to have that top level def. What's this one? This one's going to be turn right, or yeah, turn right. So it needs to have that top level on the left margin, and it needs to have everything else indented underneath it, and you have to be consistent about that. Just as a matter of speaking, if you see different computer languages, a lot of the time the white space doesn't matter, and here's why. When you define a function, say in Java or a different language that we're not going to use this semester, they often use these little curly braces to indicate where a program or where a function starts and where it ends. So if you're working inside of a different language, this white space, like this would break in Python because these are all aligned differently. But in like Java, for instance, this chunk of code that wouldn't work in Python, as long as it had a curly brace at the start of the function and a curly brace at the end, it knows that anything between those 2 curly braces belongs to this. But Python doesn't work that way. Okay, Python is a simple language, so it's very easy to use, but you have to do things exactly right with regard to space, otherwise it breaks right away, because it's got no other way to tell what belongs to what function. Okay, so that's very quickly how you make your own functions and how you can import them either 1 by 1 or 2 out of 5 or whatever, or the easier, and the one I use, just import star to get all of your functions over, and then you should be able to use them in here. So once we've got them, once we've got them in here, we can solve this problem relatively easily. The big issue on this one is we know there's going to be dandelions along the way, but we don't know how many there are going to be and where they are. So what we have to do is we have to build our program in such a way and it checks each step. Do I need to pick something up? If I do, I should pick it up and then I should move on. One of the nice things about this step is that there's only ever going to be one dandelion in any given place. So you either pick it up or you either pick one up or you don't pick one up. But you don't have to worry about, are there 3 dandelions there or 5 dandelions there. So we can use a relatively simple looping process to make a short program that will take care of this. The other thing that's helping us out here is that there's a set number of spaces in this program. The length of the room doesn't get shorter or longer, so we know that we're always only going to have to check from here to here. So how many is that? That's this is where you plant them. So we're starting here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's only ever going to be a possibility that we need to pick up 11 dandelions. So we're going to use that knowledge in our repeat in order to make that to make it happen efficiently. We start at the checkered flag, so we have to move forward before we start checking our dandelions. And so let's put a repeat, okay? And then what did I say? It was 11 times, but I think I've got to check 12 times. I could confirm that later. So I'm going to repeat this entire process 12 times. Now, what am I going to repeat? Again, this is where it's important that we have indentation proper, because anything that I put indented under repeat 12, it's going to do 12 times. What do I want it to do 12 times? Well, I said I wanted to check every space, whether does it have a dandelion or does it not have a dandelion. If it does have a dandelion, so I know I need an if statement. If it does have a dandelion, I need to pick that dandelion, and then I've got to move forward to the next one. If it doesn't have a dandelion, I can skip the picking part and just move forward. So those are the 2 options. They're mutually exclusive. It can't be both. Either there is a dandelion there or there is not. So we need to check that. And because I need to check that 12 times, I've got it inside this repeat loop. So what do I need to do to check for a dandelion? I need an if statement. So there's an if, and then if what? If some condition, and we said it's if there's a dandelion there. It doesn't matter if it's a dandelion or any other object. The code that you use for checking if something's there is object here. So object here. So we're spell it right. So we're checking, is there an object right here? And if there is an object right here, I want to pick it and I want to move. If you're ever unsure as to what you can check for in Reborg, you just go up to the Reborg keyboard, and then you go to the conditions, and these are the things that you can use in your if statements. You can check if you're at the goal, you can see if the front is clear, if the right is clear, if there's a wall, if there's an object here. If you're carrying an object, that means if you've got a little bag and you've got stuff in your bag, or if you're facing north. Those are really the only things you can check for, and you've got to be kind of creative on how you use these based on what problem you want to solve. In this case, I'm just checking if there's something on the place I'm standing. So the only thing I need here is if object is here. And I just realized I only moved once at the beginning. I have to move twice, because if I move once, I get to the part where I'm standing on where I want to plant the dandelions. There isn't going to be anything there. So I need to move twice, right? Because I need to move to this place, and then I need to move once more before I start checking. So I'm going to move twice. And then 12 times, I'm going to repeat this process. If there's an object here, and remember I need the colon there, and then it's indented again. It tries to do it automatically to help you out. So what do I want to do if there's an object here? I want to pick up that object. So I believe that's a take command. And again, if you can't remember what it is, you can just go up to Reborg's keyboard and see, how do I take something? Commands, take, right there. Okay, so if you ever forget what you can check or how to do things, you just go up to that Reborg keyboard and it'll give you what you need. So if there's an object here, I'm going to take it and then I'm going to move, because I know there can only ever be one dandelion. Okay, the only 2 options are there's going to be a dandelion and I'm going to pick it, or there's no dandelion and I move. Sorry, if there's a dandelion, I pick it and then move, or if there's no dandelion, I just move. I skip the take part. So the if statement, you'll notice, is indented. So that's how we tell it belongs to the repeat. So now we're just talking about those containers inside containers inside containers. The repeat 12 is the big outside container. The if statement is another container inside the big container. And then the take and the move are in another container on the inside of that. So I don't know if you've ever seen those Ukrainian or Russian dolls where it's like a big wooden doll, and then you open up the wooden doll, and there's another wooden doll inside, and then you open that one up, and there's another one, and another one, and another one all the way down. It's the exact same idea with programming. Okay? So we're actually down to the third level. Repeats the first level, ifs the second level, and then the take mover the third level, and those are the only levels we're going to need. So the if statement is if there's a dandelion, we're going to take it, and then we're going to move. But the other option is going to be our else. So if it's this thing, I'm going to do the take and move. Else, okay, the else is there's nothing there. So if there's nothing there, I just want to move. I have to skip the take part. Otherwise, I'm bending over and trying to pick up something that isn't there. Okay. So it's only ever going to do one of the if or the else. It'll never do both. It either does the if it's true, or it does the else if it's false. It'll never do both. Okay, so let's see where this gets us so far. On our code, Reborg is going to move twice. Oops, I cannot have an internal JavaScript error. Okay, now that's a weird error. That's not something you should run into. I might just have to refresh my browser here. Well, you gonna get rid of everything I had? Of course you are. That was just my website crashing, so I have to do. Unfortunately, I have to do this over again. Repeat 12 if object here take leave else, and the else is always lined up with the if. Okay, else is always lined up with the if, and then if there is no object there, I'm just going to move. I'm just going to copy this code in case that I get that error again. And let's just see where this takes us to. So he should move twice. Yeah, okay, I'm having some serious problem with Reborg. Close her down. Pull her back up. I break Reborg. Oh, my old code here. Okay, let's turn around. I got to put my other right. Was now that I know how to use repeats, I'm just going to use repeats. So it saved me all of one line of code here, but 3 times turn left. That's my turn right. Turn around is all good. From library import star. Move twice, and then repeat 12 times. If there's an object here, take it and move. Else, just move. I don't see anything wrong with that code. I am completely unsure why I'm getting errors right now. Yeah, I think I broke. Reborg. So I'm going to open it in a different browser and then just see if that's going to work. I'm going to open Firefox and see if it works. Can you see my Firefox window?
Yeah.
Okay. It is definitely very possible that there's something going on the Reborg server end too. And there's not much I can do about that. I'm going to take out the library part for now because I don't feel like typing out those code in the library again. Let's see if we get the same error. Okay, now it's working. Okay, so there's 5 dandelions this time. Every time he moves, he's checking. And I'm just going to stop this for now. I'm going to pause it and just go step by step by using my slider here. So he moves twice. That one's pretty obvious. Then we hit the repeat 12. So it knows already that it needs to repeat 12 times. Okay, so the first thing he does is he checks, is there an object here? Well, there wasn't one at the first spot he's at. Okay, just randomly, there isn't one there. So he's not going to run the if part, he's going to run the else part. So this, because the condition check was false. Is there an object here? False. So it moves to the else, and now it's going to run that else. After it's done that, it goes back up to the repeat 12. Now it knows it's got to repeat it 11 more times because it already did it once. Okay. So now he's checking, is there an object here? Well, this time he is standing on the dandelion, so we're going to have him take it, and then he's going to move forward again. And because it did the if, it doesn't do the else. So after it's done doing the if, it moved back up. Now it's basically at repeat 10, so it's going to check again. So I'll just keep sliding through this, and he's either going to pick up the dandelion and move each time, or he's just going to move. And once he's repeated it 12 times, okay, I hit a wall, which means I repeated too many times. So I probably needed 11 instead of 12. Let me just check this quickly. If I repeat 11 times, good. Okay. Now it's telling me something's wrong just because I haven't completed the program, but I didn't get an error. So what's happened here is I've made it all the way to this wall, and I've collected 6 dandelions along the way. So now I have to do the second part of the program, which means I have to turn around. I have to go all the way back to here. I've got to deposit those dandelions in the garbage or whatever, and then I got to move one more step to the end. So I can use another repeat for this instead of having to go move, 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 move. It's inefficient. What I want to do first is I want to turn around, and then I want to use a repeat. So now I do need my turnaround, so I might as well put it in my library. So I'll just type out all this stuff that we had before. Define turnaround is turn left twice. Turn left. And then I'll also put turn right in here in case I need it later. Define turn right. And I'm going to use my newly found friend repeat to save me one whole line of code. Instead of typing out turn left 3 times, I'm just going to put repeat 3, turn left. Now, because I have things in my library that I need to bring it in from library import star. So it's going to bring all of my library items in. And let's just make sure everything's still working. So he should be picking and moving all the way to the wall. Internal, okay. Well, clearly, import star. I spelled library wrong or something? Import star. Okay, that's weird. That always works for me on my other assignments. I don't know why it's giving me stress on this one. Anyway, I will just manually import these ones that I need. And turn right to the other one. And just give me that JavaScript error again. Okay, so he's going to check, he's going to go, and he hits the end, and he stops at the wall. He doesn't hit the wall. So now we're in a good spot where we can use that turnaround. So we're going to turn Reborg around. He's facing this way now. Now, how many times do I have to move to get him to where he's going to start dumping the dandelions? Okay, so I'm just going to manually count. He's got him, after he turns around, he's got to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. He's got to move 12 times to get to the pile. So I'm going to repeat 12 times this time. And all I want to do now is I just want to move because I'm already facing the right direction because I turned around. So this should get me on top of the garbage pile where I need to dump my dandelions. Run the code. Okay, I'm just going to skip through it quickly. Okay, he makes to the end. Right here, he hits the turnaround. So he turns around. And then 12 times he's going to move. So he's moving 12 times. And he ends up where we want him to end up. And we just got to finish off the program. We haven't learned how to use while loops yet. There is a better way to do this, but we haven't learned that yet at this point in Reborg. So what we have to do here is we have to check a certain amount of times. Do we have an object in our little bag? And if we do, we should put it down. So the most amount of dandelions we can possibly have, okay? The most amount of dandelions we could possibly have is 11, I believe. So we should repeat 11. And what we're doing 11 times is we're going to check, do we still have dandelions? If we still have dandelions, we are going to, we're going to take them out and throw them in the garbage, right? So let's repeat 11. If the condition is, if we have a dandelion. So if carries object, and again, it doesn't matter what object it is. In this case, it just happened to be dandelions. So if we carry an object, what we want to do is we want to put that object down, and the command for that is put. And if we don't have any objects, okay, then we want to move, okay, because we're done. If we're out of objects, we're done. We want to move to the finish line, and then you can end the program right away by just saying done. Let's see if this works, or if we have to make some changes. So I'm going to skip through it again very quickly. And we get to the end, we turn around, we come back. Now we hit the place where we're supposed to deposit them. So now we're going to check up to 11 times. We may end the program before we hit 11. In fact, we will. But the most we could possibly have is 11. So we got to check at least 11 times on the off chance that all 11 of those spaces had dandelions. So step by step, it's going to check. Do we carry an object? The answer is yes. We have, I think, 2. So if we have an object, that's true. So we're going to do the if part. So we're going to put it down. Okay? And that's all we told it to do. So now it's going to go back up and it's going to repeat again. It's going to ask the same question. Do we have an object still? Yes, we do. So let's put it down. Now, the third time we go up, it's going to ask us again, do you have an object? And this time we're out. We deposited the only 2 we had in the garbage. So it's going to skip over the if statement. It's going to go to the else, which is part of the if statement. And it's going to do what we have it to do under there. So we said, okay, you're out of dandelions. Now you should move forward to the goal. And because you're at the goal, the program should be over. Okay. So I guess the important part of that is building in the potential for Reborg to have anywhere between 0 and 11 dandelions. We don't know how many he's going to have when he gets to the end, but we know it's going to be somewhere between 0 and 11. Now, in this case, we only had 2. So even though we told it to repeat 11 times, because we ran out early, we had it built in. We had the logic built in to say, if we're done early, that's great. We're going to move ahead and we're going to end the program because we know we've done everything that we need to do. So that's a really good, we're getting further into our understanding of how to use those 5 major concepts in programming. First, input and output. Well, clearly there's output, from the computer this time, because we can actually see on the screen Reborg moving. So that's a form of output. Data types and variables, not so much in this one. We did a lot of that in Scratch. If statements, we call them conditionals, but if statements we're using all the time in Reborg, and we had to use how many in here? 2. So that became very important for this program. Looping, or iteration, sometimes it's called. So repeating events. Well, we had to use repeating events 3 times in this one. 4 times if you count my library function here. So we used a lot of looping in this one. And then the 5th one is functions, and we had to create functions in our library to do things like turn around or to turn right. And if we thought it made our life easier, we could have made a function that included the if object here part. It wouldn't have saved us any code in this case. In fact, it would have cost us more code. But let's say that we're in a situation where we had to use this chunk of code several times in our program, and we couldn't use a loop like we did here. Instead of copying and pasting this code 5 times, you would want to build a function, and then you just have one line that'll run all 5 lines of those codes. So you're going to see that more often as we move forward in Reborg. There's going to be situations where you need to check something a bunch of different times, and you're going to find yourself looking at your code and saying, well, I see this exact same chunk of code 5 times in my program. That's inefficient. That's an opportunity for me to create a function with those 5 lines of code so that I don't have to copy and paste 5 lines every time. And obviously, the bigger the problem, the more code that you have in your solution, the uglier it gets. So you really want to focus on, after you've solved the problem, looking at your code again and saying, is there anything I can do to make this code a little shorter, a little easier to read, use fewer resources, that sort of thing. That's a very important part of the process. It's not just doing it right so that it works. It's doing it right, efficiently, elegantly, so that you use as few resources as possible. And I think I've used this example before. For our code in the programs we're building in Python, it's not going to matter at all because we're just dealing with, at most hundreds of pieces of information. But if you're Google and you've got literally trillions of pieces of information on your servers, and you've got entire warehouses taking up multiple city blocks of big machines doing all sorts of work all day, every day. Well, there's power bills associated with that. There's wear and tear on your hardware. There's internet costs. There's all sorts of things that cost a lot of money when you're dealing with the type and scale of data that they're using. So those little efficiencies that you can use to make your code quicker and shorter and more responsive ends up saving millions and millions of dollars, billions of dollars, for big scale projects like that. So again, it doesn't matter so much for us now, but if you're working in the industry later, you are definitely going to have to consider how many resources your particular code requires to run properly, and you got to get that down as efficient a solution as possible, while still being accurate, and while still not breaking, and while still being well enough written that other programmers can look at it and understand what's going on. That's a reasonably comprehensive little review of one of the middle reborg sections. Are there any questions about what I did there or why I did it? Taylor, does that accurately answer your question about how to build functions and then bring them over? Good. Again, I'm still a little funky on why the from library import star isn't working. That I've used that for years, so I don't know why all of a sudden that's not working and giving me a JavaScript error. So that's that's the only confusing part for me right now, is I'm not sure why that's working. Yeah. Yeah, so I'm at a loss for that one right now. So you might have to import your functions one by one. I might even actually email the guy that built this, because I swear I've been using that for years and years and years. Checking something here. Yeah. Yep. Not sure why that was happening. Oh, why didn't it work that time? Did I take something out of my code that I've had before? No, it's working. Okay. Okay, so that answered Taylor's question, and as is usual in this course, people are kind of at all different parts of the course. Some people are, amazingly enough, already moving into our Python unit, which is great. They're doing well and shall continue to do so. Some people struggled a bit more with the Scratch stuff and are still kind of finishing that up. And some people are at the start of Reborg, some people are in the middle of Reborg. And so it's not unusual for this class to have students sort of all over the place with regard to what they've completed. Again, my only concern is that falling behind and staying behind in this class, once we get to Unit 4, it does represent a fair amount of a workload increase. So being behind at that point it makes it very difficult for students and adds to the stress level, certainly nearing the end of the quint. So my recommendations are, if you are feeling like you're a bit behind right now, see what you can do in the next week or so to bump yourself forward. Lean on me for the help you need. I'm not going to give you the answer, but I'm always try to kind of point you in the right direction with some hints and pictures and whatnot. And it seems to have been working very effectively so far. People are asking me questions via email. I noticed something in their code. They're missing a bracket, or they've got it in the wrong spot, or in Scratch they're using the wrong type command, and I can usually just take a screen cap and point to it with an arrow and say, hey, your problem's right there. See if you can fix it. If you can't, let me know. And people have been very responsive about that. They've been sending emails back saying, yep, that worked, thank you, we're on to the next one, or I tried that and then something else broke, and then we just continue on until we fix the problem. So I'd like to continue in that vein. Do your best to catch up if you feel like you're falling behind a little bit. I'm not intentionally assigning work to be done over the spring break or Easter break or whatever you want to call it, but it's there, and it does represent an opportunity. If you feel like you're behind at that point, you're a little concerned about moving into Python, being behind, you've got that week. It might be a good chance to knock a couple projects off to catch yourself back up. What you definitely can't do is look at that and say, oh, I've got a week break coming up, So I'm going to work less and because I know I'm going to work during that week, because what happens is you get to that week and you enjoy your time with your family and friends and whatnot, and you end up not doing the work and you end up further behind. So you can use that week to help yourself kind of catch up, but don't take your foot off the pedal right now. We've got 2 weeks until that break. Keep working hard, and maybe you're caught up by then, but if you're not, it does give you a little bit of an opportunity to do a little extra work to make sure that you're on the same page as or at the level that you need to be in order to do Unit 4 properly. Are there any other questions or programs, assignments people are having a little difficulty with that I can help you out? Zane? Yep, sure. Ask your question. Okay. Type it out as best you can. Step 16. Okay, we're moving ahead quite a bit here. So this is, for those of you who are not here yet, this would be I'm going to say next Tuesday kind of deal. So I get 3 days ahead. Sounds like a lot in a quint. Okay. Number 16. Ignore this code. This code was. All right. So in step 16, I believe the size of the field changes and the number of carrots changes. So there we go. So we've got, actually the size of the field doesn't change. The number of carrots changes. So we've got random number of carrots in random places, and every time you reload it, it's going to get a different set of carrots. There's always only going to be one carrot in each spot, though. So that's kind of a limitation of the program that makes it a little easier for you. You only have to check for one carrot. You don't have to keep checking until you've picked all the carrots. So if you're not at step 16 or in this range where you're using while statements yet, this is probably going to seem very, very complex and over your head. That's okay. You're not supposed to skip from step 8 to step 16. You're learning the entire time. So if you're not at 16, don't panic by anything you're seeing here, because you will be there if you're following the steps. You'll be at this level when you're there. Okay, I need help for step 16. Help with what specifically? Because I know I have some hints in the it's either in the assignment itself or it's in the main level in module 3 that give you specific hints on how to solve this properly. I'm sure of it. Try to figure out how he makes sure he goes around the field and picks up carrots if there are some. The assignment information is quite sparse. Let's go have a look. Okay. Oops, don't want to see that. All right, let's go to my Blackboard. Log in. And sometimes. All right, so we'll skip over this part because you are asking me specifically about assignment 16. Help with Reborg 7, 15 to 18. Hints for Reborg 18 and 20. I could have sworn I had hints for 16 in there. Maybe I don't. All right. So, 18. All right. So, Reborg step 18. Because I definitely do have some very good hints for you. This is the big one right here. Nested repeat. Nesting means putting something inside something else. So it's that idea of putting an if statement inside a function, or an if statement inside another if statement. This time we're going to use a repeat inside a repeat as we check through things. Okay? And pseudocode is just basically trying to give more in plain English explanation of what you want to do with your program, and that comes down to my strong recommendation that for these more complex reborg exercises, that you jot down some of the things that you know you need to accomplish and the order in which you need to accomplish them, because it'll make your life a lot easier when you're actually getting to programming. All right, so step 15 to step 18. 1920. I wonder if, sorry, I'm just thinking about, I know I had a hint for this, but I'm wondering if I maybe did it in a live session like this and I didn't post it. So in any case, after this session, I'll put a little hint thing up here between 3.5 and 3.6 to help you out with this. And I want to do this one. I kind of did 7 or 9 or whatever that one was, 9. For you, and I don't want to do that for this because the problem solving in this one is really important. So what I'm going to do is I'm going to help you build the algorithm to get you started, and then you can email me or whatnot later if you're really struggling with it. But get rid of my tab for reorg. I did. Okay, so I'm just going to make myself some comments here. I still got my library. Okay. I'm going to make myself some comments here that include the steps that I need to take, or the algorithm, the things that I need to do, and the order in which I need to do them, and then I'll worry about the code later. So this is going to kind of be a mix between algorithm and pseudocode, something that helps me organize it. So what we need to do here is the size of the field never changes, so that's something I know. So the size of the field is, I believe, 6 by 6. So there's a possibility of 36 carats, but in likelihood there's going to be fewer. But at the top end there could be 36 carats, and on the bottom end there could be 0 carats, some random number and some random placement between them. The first part of your algorithm is normally pretty simple. It's just get yourself to the starting point. Where do you want to start on this? And there's a couple different ways to do this. You can either make it so that you have a harvest function that starts on the left and moves to the right, and then moves up a row and starts to left and moves to right. Okay? As long as it's consistent and orderly, that will work fine. Another way you could do it is you could harvest going up and harvest coming down and harvest going up and whatnot. The fact that the field does not change size makes this one significantly easier than number, I'm going to say 19. There's another one where you harvest carrots where the field changes sizes and the number of carrots changes. So this one is significantly easier in that we know the size of the field and the total potential for carrots. So what we want to do first is we want to move. Let's move reborg into position, I'll call it. So where do I need to go just to get started on this whole thing? And it looks like I need to move, turn left. Sorry, move, turn left, move, and then I'll move out. I'll take care of everything else after that. So move reborg into position. I'm just gonna make myself a little note. Move times. Can't remember 1, 2. Okay. Move times 2. Turn left, and then move times 2 again. So that's what I would consider pseudocode up there, because I'm not going to type out the whole thing, but I know when I look at my notes that M is for move. So move 2 times, turn left, TL for turn left, and then move 2 more times. So that's just some pseudocode to remind me of what I need to do. So after I am at that position right here, now I need to start thinking about what function I need in order to check if there's a caret, and if there is a caret, take it, and how many times do I need to run that. So I'm going to say make harvest function. Check and take carets. So that's something I need to do next. Keep moving forward. checking, and then I'm going to put times 6 because I know that there's not 8, 6 times 6 because I know that there's going to be a maximum of 6 times I need to check because that's how big the field is, right? Then I need to find a way to change, what would that be, a column, I guess, change column. Okay. And then I need to, again, run harvest, moving in the opposite direction. So I'll say change column slash TA for turn around. And then I go to run harvest again, moving the other direction. And I got to do that. I've got to do that 6 times, right? Times 6. Because I'm taking care of 6. Let's just say I'm gonna move up and down on this harvest. So I know that I need to check for 6 carrots, but I also know that I need to do that 6 times because there's 6 rows and 6 columns. So it's basically 36 total checks. So I need to run the harvest, moving the other direction. I got to do that 6 times. And then at the end, when I'm done, let me just check my motion here. So I'm moving up, down, up, down, up, down. So after I've run the harvest 6 times, I'm going to be right here. So what do I need to do from that point in order to get to where I need to dump my carrots? It looks like I'm going to need to move down or move forward, and then I'm going to have to turn left and then move again. So my next step in my algorithm is going to be move times 2, I believe it was. Move times 2, and then it's going to be a turn left, and then it's going to be a move again. And then my last step is pretty easy. Dump all of carrots and done. Done is the command for the end. So that didn't take me very long. I did it and explained it in about 5 minutes. It's going to take you probably 45 seconds to build that algorithm and jot it down. And the nice thing is once you've got the algorithm there, you can just continue to refer to it and then make sure that you are following the steps in sequential order and that it's doing what you want to do. And if some part of your algorithm isn't working and your code isn't the way you had it described isn't working, you can just go back up to your algorithm and change it, say, to what you need it to be. So then you work with your algorithm, and the first part I think is a good part to kind of just get you going because you can always do the first part. The first part is I just got to get him in position. So that's easy. I mean, so all I got to do is I've got to move him twice, right? So I'll just move. Then I got to turn left. So turn left. And this is kind of the confidence building stuff, right? Because you're making some progress even if you haven't solved the main issue in the program. Move, turn left, move. So let's see, and then just keep testing. Let's see what happens here. So if I run it, move, turn left. Okay, now I probably went one too far because I'm actually into the field. Now that's okay if I start checking right away as my first order of business. So I'll just go with that for now, and if I need to adapt it later, I will. All right, so I basically checked off number 1. So let's move on to number 2. I need to make a harvest function that checks and takes carrots, and it needs to do it 6 times. All right, so I know I need a harvest function, and your functions always come at the top. Okay, now I normally, at the end I'll delete my algorithm. Usually your import is your first statement if you have one, and then sometimes I have a think statement so it moves quicker, and then your function. Your functions always need to be either in your library or above your code. So I'm going to just put it in my code this time. I'm gonna call this define check and then harvest because it's really going to do 2 things. It's going to check to see if there's something there, and if there's something there, it's going to take it. So here's my function. It's called check harvest. Now, what does check harvest need to do? I'm going to be standing in this spot right now. So what it needs to do is it needs to check 6 times. So I know I need to repeat 6 times, and I need to check. So if object here, there's an object there, I want to take it, and then I want to move. Because once I take the object, I know I'm moving to the next step. And the only other option is if there's nothing there, then you just move. And that's very similar code to what we had with the dandelions, right? You either took it and moved, or you just moved. So I'm going to repeat that 6 times, and what that should do is that should get me out the top end with carrots. So let's check and see if it works. So let's just run check harvest and see if it works and see where it gets us. Okay, so I'm just going to run it quickly here. So I turn left, I move, I'm inside, and now it's going to run check harvest. So it goes to my function. It says, I have to do this 6 times. Is there an object here? Yes, take it and move. Okay, now I'm down to repeat 5. Is there an object here? No, there isn't, so I'm just going to move. No object, so I'm just going to move. There is an object, I'm going to take it and move, take it and move, take it and move. And now I'm exactly where I thought I was going to be. I'm at the top. Okay, I'm at the top of my field. I've collected all the carrots. I didn't move too far. I didn't move not far enough. So that was a successful implementation of this particular code. Now it asks us to use a nested loop. You don't necessarily have to in this case, I don't think, because you could have what is essentially a turnaround feature. So in this case, I know now that I'm through the first column. So the next logical step is for me to turn right, move, and then turn right again. So I'm facing downward, right? So I might create a function called, turn harvest or something like that. I don't want to call it turn around because I already have another turnaround function. And I actually don't want to turn around because if I do turn around with my existing function, I'm still in the same column. I know I need to move over a column. So I might create something called turn harvest, just keeping it in the harvest theme here. And for that, I know it looks like I need to turn right, which I have from my library, and then I have to move, and then I have to turn right again, and then I have to move, right, and then I have to move again to get inside the field. So I'm just going to check this out, and I also need to make sure that I bring my library in. From library, import turn right. So I might as well import the other one too in case they need it. Turn right. All right, so let's see where this gets us to. This should get us to the next row, set up and ready to go. Boom, 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 boom. Oh, I guess I've actually got to run turn harvest as well, right? And you know what? You can put this actually inside the other function. There you go. So I'm where I want to be. If I didn't want to run this here every time, there's no problem whatsoever in taking this entire function where it says turn harvest. There's no problem in taking this and putting this inside the top function, because as soon as it's done repeating 6 times, it's just going to do the next step in the program, which is turn harvest. So if it sees turn harvest, it's just going to go down here and do these things. So it can actually be part of check harvest, even though it's a completely different function. You can use it inside other functions. That's nesting right there, actually. It's this function here is nested inside, or sorry, this function here is nested or called from within another function. It's actually called recursion, but it works. So when I run this, it'll work exactly the same way as it just did. It just might save me a little code in the end because I don't have to repeat it that many times. So now I'm actually set up for the next row. I'm in the first spot, and then I can run check harvest again. And I think that's probably even a bit more help than I should have given on this one, but I think you see what's starting to go on here. All right. Ooh, yeah. Now that's actually, I'm glad that happened. Okay, so have a look here. Now there's a difference going up and going down, right? If you're going up, turning right sends you this way. If you're going down, turning right sends you the other way. So, so depending on which way you're facing, you're going to need a different turn. So for turn harvest, I might need to have 2 different things in there. Okay, so depending on which way you're facing, so I might have to have a turn harvest U for up and a turn harvest D for down. And I'm sure there's a better way to do it, but again, a lot of the time I'm building my program so that it works, and then I'm trying to make it more efficient. So, so because I'm facing up the first time, I would do turn harvest U, because I know I'm facing up, and then the second time I would do turn harvest. And I'm already thinking of ways where I can make this more efficient, but so far I'm getting through my algorithm, and then we'll worry about efficiency later. So there he goes, second time, and this one I have changed. I forgot to change this, but this one needs to be turned. Oh. If he's facing down, he needs to turn left instead of right. So now let me run it again quickly. And now we've managed to get through 2 rows, and same problem. Again, glad we're running into it, because if you didn't test it and you just kind of did it in your head and you thought it would work, and then you go in your program, run your program, you're like, oh my God, this doesn't work at all. I forgot to consider this and I forgot to consider that. That's why you just test. So I had an additional problem there. My harvest or my turnaround when I'm going down, he went the wrong way, right? So I'm at this point right here. I need to, if I'm facing down, I need to turn left first. That was my problem. I had it in the wrong spot. Then I've got to move and I've got to turn left. Move, and then I got to turn left again. So let's just see if that works, or if I've made another mistake there somehow. Okay, no, that worked. So now I'm back in there. No, now that you've completed a process once, as soon as you've completed it once, you can complete it as many times as you want using while statements or looping with repeats, and there's 1,000 different ways to do it. So what I would do is I would continue to kind of check through this list here. I got rid of number 1. I made a harvest function that moves forward. It checks 6 times. I managed to find a way to change the column by using that turnaround. Now I'm going to run the harvest in the other direction. And then at the very end, I've got to find my way to the carrot dump and dump. So I've actually, in this reasonably short period of time, made it up to number 4. And I might change slightly how I do number 5, because I didn't use a repeat inside a repeat. It's probably more efficient to use a repeat 6 inside a repeat 6, which 6 times 6 is 36, because you need to check 36 times. So I'm already thinking about a more efficient way I could do this with a repeat 6 inside a repeat 6. But ultimately, I'm going to get this program completed once so that it's working, and I'll always have that in my back pocket. So let's just say I do this program, I get it completely working, I get the green arrows and everything's good, and it's working, but I know that there's a better way to do it, or maybe I didn't use everything in this world info, okay, that I needed to use in order to get full marks. For instance, this one says, remember, you can have a repeat statement inside another repeat statement. It doesn't say you specifically need to use a nested repeat. It's giving you a hint saying that it might be easier to do it this way. So if I've completed the project and it's working properly, this is an opportunity where I would go and I would save a copy, and I would just call it, whatever you call it, step 16, and know that I have that saved somewhere in case I screw up my code. Okay, so you're basically making multiple versions of your code just in case. So once I've solved the problem and it's working, but it's maybe not as efficient as it could be, save a copy on your computer. Now you have the freedom to come back here and say, well, I need to make this more efficient. How can I make this more efficient? Well, maybe doing a loop, a repeat inside a repeat, a nested repeat, might make this a little easier or a little bit more efficient for me to do. So if I do it 6 times, okay, 1 for each row, and 6 times within that, so 6 carrots within each row or within each column, maybe I can get rid of, or maybe I can solve 90% of this problem in 7 lines of code instead of having to repeat this chunk 6 times in a slightly different way. So the natural progression of events for me there was going to be that I made my algorithm. I'm reasonably confident in it. I have some pseudocode in there to just give me some reminders of what I need to do for each step. So that was step number 1. Step number 2, okay, I'm bouncing through my algorithm, creating real code that accomplishes each one of those goals. Number 3, it's kind of with number 2, I'm constantly testing to make sure it's doing what I need it to do, and then revising my code if it doesn't. 3, I'm going to solve the problem. I'm going to get to the end of it. I'm going to make sure it's working. 4, I'm going to save a copy. Okay, so 4, I'm going to save a copy because I know it works. It might just not be the best solution, but it works. Okay, and then 5, I'm going to try and make it more efficient. So if you continue to use that process in Reborg and in your Python programs, it may seem like it's time intensive, but I guarantee you it'll save you time over the long run. It took me many years, because I'm very stubborn, it took me many years to realize that the little amount of time I spend jotting down a couple of notes can save me hours when it comes to actually building and testing the project. I'm stubborn. I was like, no, I just build it and figure it out as I go along and whatnot. No, it's actually been really, really helpful. And it doesn't usually take very long. So I'm a strong proponent of using even just a jot point form algorithm at the top of your code. And if you need to change the algorithm, you do it. And if you don't, because it was more or less right the first time, that's great. But it always gives you something to refer back to and a feeling of minor accomplishment when you accomplish or when you get through any one of the steps. And usually you can get through the first step at minimum easily. So even if you are going to struggle with step 3, 4, 5, 6, the fact that you could make it to the place where you start harvesting is a minor win, right? So it just gives you that continued feeling of advancement and pride that, okay, hey, I checked that one off, that's good. And that should be a good feeling because it's part of your problem solved. And you get to step number 3 or 4 and you're going, okay, I'm halfway done. You know, it's another sort of milestone. So I recommend that process I described to you for those reasons. All right, let me just check here. I haven't checked my comments for a while. Looks like Zane figured it out slightly differently, but it's working. That's great. Now that you've got it working, save a copy somewhere, then go back to it and see if you can make it better. Taylor says, if we have to repeat something, can we copy our own code and paste it so we don't have to type it 12 times? That is the whole point of using the repeats, Taylor. So that is a very important concept. If you've got a whole bunch of code, you should be doing one of two things. You should either be making a function. Okay, so let's just call this function do this 5 times. So you either want to have a function, or you want to have a repeat, or you want to have them both, because you do not want to be copying and pasting chunks of code down your program. It's a waste of time. So let's say I want to do this 5 times, and let's just say I want to move, and I want to do a check. So if let's just say if object here, take, and then move, and then my else is just going to be move. Okay. Now, if I needed to do this 5 times in my program, the worst thing I could do is go like this. The worst thing I could do is I need to do this here, and it's not indented properly, but we get there. It's unindented here. The worst thing you could do is if you need to do this process. Sorry, look proper. You needed to do this thing 5 times in your program. The worst thing you could do is this: copy, go down to the next, line of your code where you actually needed it. Okay, I need it there, and then I need it further down, so I'm going to need it. That's the worst possible thing you could do. Okay? It's inefficient, it's unnecessary, and it takes you longer than it needs to. Okay, so if you ever need to do something more than once, you should be building a function for it. And then what you would do in order to use this the 5 times, forgot my brackets there. What you would need to do to use this 5 times is one of 2 things, right? Either you just write the one line 5 times, because every time you write the line, it's going to do what you want it to do. So if I needed to do this 5 times code, I would literally do this 5 times, and because I needed to do it in a different spot of the code, let's just pretend that that's code, and maybe I move or do something in here. So I can't use a repeat because it's kind of all over the place. And then when I get to this part of my code, let's say I needed to use that function again, instead of having to type the whole thing out or copy and paste and have 5 extraneous lines, I can just put the do this 5 times, one line of code. But every time that it runs this line of code, it goes back up here and does these 1, 2, 3, 4, 5, 6 lines of code. So instead of having 6 lines of code every time I need to run that process, I've only have to do it once. And these moves here and whatnot, these are just, let's just say that this is just a different part of my code. And then I get down a little further and I need to run this process again. You know, you can copy and paste this line, but the point is you've only got 1, 2, 3 lines of code in your main program instead of 3 times 6, 18. So it's way more efficient. So if you need to break it up, but you still need to use it a bunch of times, make sure that you build a function. If you don't need to break it up, let's say you needed to do this 5 times in a row, that's when you would use a repeat. Then you would go repeat 5, and then just type it once, right? Do this 5 times. Now this is going to do, it's going to run this line 5 times in a row, and that's even more efficient because it's going to run this 5 times, which means it's going to go through these 6 lines of code 5 times without you copying and pasting those 6 lines of code back to back. Okay? If you didn't use the repeat, okay, if you didn't use this, this is what your code would look like. Okay, I'm gonna comment this out for now, so I can demonstrate the benefit. Okay, so if you didn't use that repeat 5 and the function, this is what your code would look like. These are your 2 options. If you want to run this chunk of code 5 times, your 2 options are 2, 3, 4. Your 2 options are these lines, so 11 lines of code, or however many that is. And if you needed to run it, if you need to run this program 7 times, well, then you got to tack 2 more onto the end of it. Whereas if you have this code instead, and you want to run it 7 times, you only need to change the 5 to a 7. And if you want to run this 100 times, you just need to change it to repeat 100. Whereas if you want to run this big chunk 100 times, you got to 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You get the idea? I don't even think you want to copy and paste something 100 times, let alone type it out every time. So yes, the answer to your question, the short answer, I kind of gave the long answer there. The short answer is if you have to do something more than once in your program, you should be using a function and or a repeat. If you have to do it 5 times in a row or 10 times in a row, exactly the same thing, you should be using a repeat. If you need to do something at different parts of your program, but it's the same thing. Let's say I need to do a check for an object at the top of my program, and I need to do it somewhere in the middle, and I need to do it somewhere at the end, then you should have a function so that you can just sort of call it anytime you want, but not necessarily in a row. Does that make sense, Taylor? All right, we've been going at it for hour 15. Got through some more pretty good concepts, I think, in Reborg. Does anybody have anything else that they want to look at, or are we feeling okay? Because if we're feeling okay, you can feel free to move on and enjoy the rest of your afternoon and have a great weekend. Never hesitate to email me if you're struggling with something. I might not give you the answer, but I will do my best to point you in the right direction.
Have a good weekend.
You too. Take care. You are most welcome. Take care, Taylor. Zane, have a nice weekend. You know what, Zane? That's a compliment. Because if you're not frustrated, you're not learning. Hopefully the exaltation and the feeling of victory when you overcome a problem is greater than the frustration you put into it. That's the goal. The harder the problem is, the better you feel when you solve it, I guess. And you're clearly solving things, so that's great. Is that Ernie Hudson? Kind of looks like Ernie Hudson.